AI agent edit your videos. One HTML file, one terminal command, full YouTube video, no editor. This is the complete pipeline: script, audio, timing, and render. Every step. Skills harness AI agents all in one personal monorepo. We're open sourcing it soon. Subscribe so you don't miss the drop.
You're watching a video I made with an HTML file and one terminal command. No Premiere, no DaVinci, no editor at all. Claude Code wrote the scenes. HyperFrames rendered them. Here's the full setup.
For most of last year, video editing was my biggest bottleneck. I had the ideas, I had the scripts, but getting from a finished script to a published video took 4 to 6 hours per piece, and almost none of that was creative work. It was adjusting clip lengths, re-recording audio because the timing ran long, fixing sync errors that only showed up at final export. The problem wasn't creativity, it was setup. I wasn't structuring the work before jumping in, so I changed that. Now I write the brief, write the script, generate the audio, and measure every file before I ever touch any visuals. Once that structure is in place, the rest runs. Claude Code writes the scenes. HyperFrames renders the video. I went from 5 hours in an editor to running one command. This video is that workflow, start to finish. HyperFrame scenes are files, text files. That's the unlock. Every scene in this video is an HTML file that an AI agent wrote. I didn't write any of it by hand. I opened Claude Code, described what I wanted, show the folder structure, items appear one by one, data duration 38.9 seconds, and the agent output the file. Done. The reason this works is that HyperFrames stores video as code, not as a project file you open in an editor. And code is something AI agents are really good at. You can't tell Claude Code to drag a clip to the timeline, but you can tell it to write the scene. That's the entire insight. The workflow in this video is built on that one idea. If the video format is code, then an AI agent can build the video. Getting started is one command, npx HyperFrames init. It gives you the skeleton index.html, a compositions folder, an assets/audio folder, and meta.json where you set your voice ID. That's HyperFrames out of the box. What this repo adds on top: insight.md, script.md, narration.txt, and a skills folder. That skills folder is the important one. It gets symlinked into Claude Code's skill directory. So from session 1, the agent already knows how HyperFrames works, the data duration rules, the timeline registration syntax, the audio sync gate. You don't re-explain the framework every session. The repo explains it once. The workflow has 6 steps. 2 are yours, 4 belong to the agent. Step 1, insight.md. You write it hook, argument, audience, keywords. Step 2, script.md. You write it 1 VO block per scene, 1 timing estimate per scene. After step 2, you hand off. Step 3, the agent generates all audio from narration.txt. Step 4, FFprobe measures every file, exact decimal, no rounding. Step 5, the agent writes index.html, but only after the timing table is filled. That's the gate. Step 6, render, one command. Here's the insight. Steps 1 and 2 are creative decisions, only you make them. Steps 3 through 6 are deterministic execution. The agent runs them without judgment calls. The gate between them enforces the handoff. You do not write HTML until FFprobe is done. I rebuilt 2 videos from scratch because I skipped this. That one rule eliminated every sync error I was hitting. The pipeline has 2 modes. Default, 2 human checkpoints. You write insight.md, you approve it. You write script.md, you approve it. After that, the agent handles audio, timing, HTML, and render without stopping. That's steps 3 through 6 running automatically. YOLO mode, no checkpoints. The agent runs all 6 steps on a schedule and drops a rendered MP4 in the renders folder. No input from you. The harness enforces whichever mode you configure, but both modes depend on the same thing, the skills. Without them, even default mode requires babysitting. The agent doesn't know the timing gate, doesn't know data duration must be FFprobe exact. With the skills loaded, both modes are production ready on round 1. The gateway is optional. The skills are not. The repo ships with the gateway on by default. Creative decisions stay yours. Execution belongs to the agent. Run npx HyperFrames TTS. It reads narration.txt one line per scene, sends each to the configured voice, and saves the output to assets/audio. Once all files exist, the gate opens. Not before. I count the files. If the count doesn't match the scene count, nothing downstream proceeds. That one check has saved me from shipping a video with a scratch recording I forgot to replace. Once the gate opens, step 4 unlocks the timing table. Each scene's duration comes directly from the audio file, exact, not estimated. A rounding error compounds across the whole timeline into seconds of visible drift. Audio ending 5 seconds before the video does, or 5 seconds after, both look broken. The timing table is the contract. Every scene signs it. The repo has a skills directory. One skill.md per capability. HyperFrames compositions, GSAP patterns, TTS generation, scene architecture. Each file has front matter with trigger phrases that tell the agent when to load it. Symlink that folder into Claude Code skill directory. Ask for a composition, and the HyperFrames skill attaches automatically. You are not reteaching data duration, timeline registration, or the audio gate every session. Here's the compound. Every time you solve a new problem, a caption pattern, a transition that works, you update the skill. One update. Every session after that inherits the fix. After 4 videos, the skill file had 7 commits. The same composition prompt passes lint clean on session 8. The system doesn't forget. Practically, I describe the scene in plain language. Layout, motion, FFprobe exact durations. Claude Code loads the HyperFrames skill, writes the composition. I run npx HyperFrames lint and drop it into the project. The skill stack isn't only HyperFrames and GSAP. This repo wires in the same pattern for copy and hooks, narrative structure and video retention, strategy and editor-style pacing, not just timeline code. Encode each playbook once in skill.md. Every session inherits the whole syllabus. Run npx HyperFrames render. HyperFrames launches a headless browser, captures every frame, mixes in the audio. Output, a single MP4 in the renders folder. If the audio is silent, 2 FFprobe checks diagnose it in about 30 seconds. First, confirm the stream exists. If nothing prints, the SRC path is wrong. Second, check max volume. Below -91 decibels means data duration cut off before the audio finished. Fix the path or extend the duration. Re-render. Those 2 checks cover 99% of render failures. So here's what I want you to take away. The unlock is video as code. If the format is text, an agent can build the scenes. The discipline is the gate. You own insight.md and script.md. After that, audio first, FFprobe exact data duration on every clip, only then HTML. That handoff is what killed my sync bugs. Skills are institutional memory. Symlink the skills folder once. Record every fix in skill.md, and every later session inherits it. Default mode keeps your checkpoints. YOLO mode lets the harness run steps 3 through 6 without stopping, same skills either way. At the end, it's still one git repo, one render command, one MP4. If you want Hermes agent goals, the system that runs this on a schedule without you, that's the next video. Subscribe so you don't miss it. And in the comments, what would you hand to an agent first in your own pipeline?